So there's a lot of birds that do sort of that half migration. What's really cool is when they study migration with radar, you can use radar to look at, you can't identify species, but you can see individual blobs moving across. They've done a lot of work on the Gulf of Mexico to figure out how are birds dealing with the Gulf of Mexico, because that's a big expanse of water. They're coming up or going down. Are they going to go around it, or are they going to go across it? And usually they go across it. And as long as they don't get hit right in the middle of that passage with bad weather, they can make it. You know, they'll land on the other side and be exhausted and go down for a couple days and eat and get more energy and keep on going. But yeah, it's a risky thing. I mean, there's all sorts of stuff. I mean, this spring with the crazy weather we had this spring, were you seeing like snow geese like just down in places you usually don't? I came by Little Lake last month and there were 100+ swans on Little Lake. You never see swans on Little Lake, you know, but they got knocked down because of the weather. And so they are typically, many birds are migrating at night. And so that begs the question, how are they doing that? And it's a whole bunch of combinations of things. I don't think people truly understand yet how birds migrate, but they think that they are using a combination of things and not just one. So there is something to do with magnetic fields. There are some visual cues. There's some sun compass stuff going on there. But it's probably a combination so that if one thing gets out of commission, you know, you can continue using the other sort of thing. But a lot of birds migrate at night. And probably it's because when they do have to come down, they can spend the day eating, because they are usually diurnal birds, and then they can go ahead and continue migrating at night. There's lots feeding into it. Yeah. So I think this next slide will come. Yeah, okay. So is migration something that you learn from your parent, or is it instinct?
I think it's instinct.
It's probably both, or one or the other, depending on who you are. Because think about our songbirds. Typically, like say something's nesting in Ponderosa Park. By August, the adults have left, but the young are still here. And they're going to migrate a little bit later because they haven't had as much time, you know, all summer. They've only had a portion of that summer to be eating and putting on weight and all that kind of stuff. They need a little bit longer. They typically migrate after the adults. So they're not going together. So clearly they're not being shown the way, right? It's instinct. But then you think of the experiments they've done with cranes, where they actually have to show them where the wintering area is, right? If you've ever seen those TV shows about the guy who had the ultralight and he was leading the cranes down in New Mexico or something like that. Yeah, I mean, they had to show them where that wintering area was. So that is a learned behavior. And the cross-fostering that they did with whooping cranes and sandhill cranes, where they put young whooping cranes with sandhill cranes just so that they would learn the migration. You know, they would migrate with the sandhill cranes, so they would learn where those places are. Those are learned. But there is also an aspect of migration, which is the way they fly. So you might have some birds that are doing it solitarily, but we see a lot of big flocks of birds, big flocks of snow geese, hundreds, 200+ flock of snow geese flying over, all cackling and making noise and being very beautiful up there. So why are they doing that? What is the reason for staying together as a group in the air? And if you've watched them, there's this constant shifting of what's going on in the V formation. You know, birds in the front are dropping back and other ones are going forward, and it's really cool to watch. Well, they did a study on this. Of course, they always do a study. So they found they somehow attached something that recorded energy use on the birds. And they basically found that this V formation is a very efficient way of flying, because you're using what's happening with air drafts and stuff on the bird in front of you to assist you in flight. And so that's why there's a constant switch in who's doing the work and who's saving energy. Yes, drafting, exactly. So as a group, you can go much further than you could as an individual, right? That's what it's all about.
What birds are those?
It's an ibis, but I don't remember which. It might be like a white-faced ibis. It's not. This is England, I think. So yeah, we tend to think that the bigger you are, the stronger you are, the farther you can go, maybe the faster you can go, but that's not true at all. It may be for sustained periods, there might be an advantage to being bigger and stronger, but just achieving a maximum speed, as it says, a hummingbird can do the same thing as a goose can. Okay, how are we doing? Do we need a stretch break or bathroom break?
Whenever it's a good time for you, 'cause
What time is it?
it's like 10:15, so.
Let's do this part and then we'll take a break. Okay, so let's think about, it's not all roses out there, right, for birds. There's all sorts of, migration itself is a risk. Being out here, depending on who you are and where you are in that food web, you're either bottom of the totem pole and everybody's after you, or you're the top dog and nobody's after you, right? But there are risks out there, and then there are ways to minimize your risk, right? So you're constantly trying to figure out what's going to hurt you and how can I overcome what's going to hurt me. And then what's going to hurt you learns how to overcome it better, and you have to get better. So it's a constant flip-flop. Okay, so, but there's ways of looking at this. There's the individual level of getting hurt, and then there's the population level of risk, right? And typically we don't think that if it's bad for that poor bird to have died, but that probably isn't going to affect the population, it's too bad for that bird. But if that happens too many times, then we get a population effect, but that is a significant risk. But there's different things at play there. So if you're an individual, what are the things you might be worried about that could prevent you from surviving? A kid with a BB gun? Yeah. Yeah. So again, it's are you going to get eaten? Predation. We've got lots of things that eat songbirds. Basically, it's larger birds are eating songbirds, but you've also got mammals that are eating songbirds, or game birds for sure. Coyotes and foxes are getting those quail. And then there's the whole thing of competition for resources, whether it's food, an available nest site, a mate, all those things are ways that could prevent you from maximizing your survival. So what do you do about that? What are ways that you use to prevent risk to yourself? Tons of things you can do, right? Well, this is just an example in Charlie Ray's backyard a couple winters ago of a pygmy owl getting a songbird, I think it was a goldfinch, at his bird feeder. So you can see, the goldfinch is at risk, the pygmy owl not so much. Okay, what do? The first thing you do is you work out ways where you're not like out there saying, come get me, So you work out ways to camouflage yourself or to protect yourself. So camouflage is one of them. If you're a ground nesting bird, you figure out how to look like your surroundings, right? Some birds, it's a killdeer. Try to find a killdeer nest. It's really hard. It looks like rocks out there in the gravel. That's a strategy. They're making a decision to do that, okay? You yourself look like the surroundings. So this is a curlew on the lower right, and they nest in meadows, grassland meadows, pastures, that kind of thing. Their coloration is kind of blending in. That is a sage-grouse hen on the left, poking through the balsam root leaves, okay? So her nests are typically under sagebrush bushes with a certain, it's very then measured a bazillion times, certain kind of cover that they like to hide their nests from aerial predators. So you're not only protecting yourself, you're protecting your investment in your young, right, by camouflaging your nest. So that's one thing you can do. You can move to a safer neighborhood, or pick a nest site, if you have the capability, that is less risky to predation. And cavity nesters, that's their whole thing, right? I mean, they're in a hole. Other than a snake or maybe a squirrel, there's not a whole lot that's going to get them out of that cavity, right? You're most vulnerable when you're coming in and out of the hole, but the hole itself is much safer. It's protected from the weather. It's protected from the random, fox just sort of stumbling on your nest on the ground. It's protected from a lot of other birds because that hole is pretty small, so most things aren't going to get in there to get your nest. So that's one way, or another way of doing it. Yet another way is to swamp the predator, and that's where the colonial nesting comes in. You get colonies of pelicans or gulls or terns that are tens of thousands of birds nesting all at the same time, and their young all hatch at about the same time. And that's strictly a safety and numbers game. That's what they're doing with that. So that's another strategy. This is just a little side fun fact that even though you are constantly worrying about yourself, you can sort of tag team and make advantages to you and another bird. So this example is between herons and ibises, where the heron is providing food to the ibis and the ibis is providing aerial predator detection to the heron. There are other examples of that, not so much bird to bird, but sort of symbiotic relationships of things in nature. Oxpeckers picking insects off buffalo and all sorts of things. Okay, so threats to the population are different than what's going on at the individual level. Now you're worried about something that could have widespread effect on a lot of numbers of individuals, such that now your population is at risk. And so this is where things like toxins come in, and pesticides, or with grebes, the example of the water level dropping. You've got 1,000 nests of western grebes on Cascade Reservoir. They might all fail together, right? So that's a whole year that goes by where there isn't one chick that comes off of all those thousands of nests. It's happened. Not so much from water level, but from sort of extreme storm events that have just overturned all of the nests. Remember that thing in Donnelly that happened a few years back, all those trees went over? That year on Cascade Reservoir, every nest failed.
Wow.
Yeah, so there's things that go on. Disease is a big one with birds, and we contribute to this because we love to feed birds, but we don't take very good care of our bird feeders. And so we, every once in a while, will get these epidemic situations of disease sort of running through wintering birds that are at bird feeders, because the feed gets wet. The feeder itself allows the birds to just be standing in the feed, and they're pooping in it, and it's not getting cleaned, and then it gets wet and moldy, and then they get a bacterial infection, and then it just passes through everybody. So every once in a while at Fish and Game, I'll get this call, all these birds are dying. It's like, first question you ask, do you have bird feeders? Yes. And we'll take them and we'll test them in our lab, but they all come back, that they're all got aspergillosis or something like that. The other thing that can happen at a population level is habitat loss, and that isn't so much a one-time event, it's a gradual thing that's happening. And so what would be a good example of that? Well, for sage grouse, over the last 100 years, sage grouse habitat has declined like 70, 80 to 90% because of the introduction of agriculture. And those two things don't always work well together. So when you have a bird that depends on sagebrush and depends on a certain cover of sagebrush, when that disappears, they are not going to do well. They cannot adapt in the short amount of time that we're talking about to overcome that. climate change is gonna be a big one. We don't really know what's gonna happen. You know, for some, if it just means that there's just a shift in elevation, so we have the same habitats, they've just moved up, okay, there are lots of birds that are gonna be able to cope with that. But what about the birds that are at the top already? Where do they go? Like the rosy finches that are our alpine species, you know? We don't know what's gonna happen to that. It's a big, big unknown. What we are seeing already, and this again is gonna, depending on how quickly this happens, is that birds are arriving back, if they're a migratory bird, they're arriving back sooner than they used to, and that might put them out of sync with the insect flush that they depend on to feed their young. Because it's very much a timing thing. They're gonna start nesting when they know that when their eggs hatch, there's a ready food supply. But if they start doing that earlier and earlier, and the insects aren't going along with them, there's gonna be this disconnect of food for young. So that may or may not work out for birds that come back too early. Energy development is a big deal in eastern Idaho, not so much around here. I don't know if it's gonna come here. I don't think we really have the suitable places for wind development or geothermal or oil. But those are the big things that are happening throughout Idaho and throughout the West. And some of them can be a fairly large footprint on the landscape. And so it's a direct loss of habitat, but then there's also disturbance associated with noise. And a change in habitat that may introduce predators, and there's a whole bunch of stuff that happens. But the thing with wind specifically, not only with birds but also with bats, is just the direct mortality of the terns. And wow, it's incredible the statistics they've come up with if you go and look on the ground like early in the morning after there have been birds passing through, especially during migration, pretty high mortalities. Yeah, we need to think about that.
And are they being drawn in by like some sort of air vibration?
They don't know. They've changed all sorts of different things. It could be the noise, it could be the lights that are on them. I mean, light pollution is a really big deal for migrating birds because it disrupts this other stuff that they're trying to use, the stars, the sun compass, whatever it is they're doing, these lights. That's why we get, for decades now, they've worried about or talked about in cities, large, tall buildings that leave their lights on get huge numbers of strikes at night when birds are migrating, and you have lots of mortality in that too. That's why there was a big campaign to turn your lights off in your office building at night. If you remember that, there's a big thing in cities to lights on. It's why Valley County, one of the reasons we have a dark sky ordinance, although we don't enforce it. So these are the things that happen at a higher level than just you. Okay, this is happening to a suite of birds. It might be one particular species that's vulnerable to something, but it could be, and typically is cross species. So it's happening at multiple populations. So just something that we all need to be aware of. I mean, in my job, this is part of what I do, is to assess projects, to be involved, assessing things. It might be something simple like, if you just were to move this, whatever you want to do, here instead of here, it would make a huge difference. And sometimes it's that simple, usually not. Okay, this was an example of a population thing. We were talking about sage grouse, and we were talking about the west central population of sage grouse that is really in fairly steep decline right now. And when West Nile became a big thing in 2006 time, we all of a sudden had horses, we had humans with West Nile. If you look at what this graph is showing is these are our lek counts that I just talked about. So each color is a different lek route that we do. And these are the numbers we're finding, blah, 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 blah. Excuse me, from 2000 on. These are the numbers of sage grouse we're counting in our leks. And you can see it's kind of up and down, up and down. 2005 and 2006, we had this huge jump in West Nile cases. After that, this is where our sage grouse are. And we're quite certain that sage grouse had no defense against West Nile. In fact, in Colorado, they collected blood from I don't know how many hundreds of sage grouse, to look for antibodies to West Nile that would